So now the results. The HCl solution, it was about 0.1, but we do need to know its exact concentration, or as exact as we can get. So we standardized it. If you haven't done the standardization experiment, that's also available. Concentration 0.0986 moles per cubic decimeter of HCl. And then here's our data sheet. So trial number 1. I took 10 cubic centimeters of the mixed solution. I started adding HCl, and if you remember, I added 22 cubic centimeters of HCl, and that changed the phenolphthalein from pink to colorless. We need to figure out how many moles of HCl that is. Well, we know the concentration at the volume, that's the moles of HCl. Then we kept titrating with the methyl orange. It was yellow, 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 yellow. Then we added a total of 34.8 cubic centimeters. It went from yellow to orange. And so again, now I can figure out the moles of HCl that I added there. Now, simplistically, how to do this. This first HCl is neutralizing the NaOH and the Na2CO3 down to the NaHCO3. Then this second bit, which from 22 to 34.8, in other words, 12.8 cubic centimeters there, that's just neutralizing the hydrogen carbonate. So you've got NaOH and Na2CO3. This is NaOH plus Na2CO3, and then this is just equivalent to the Na2CO3. Enjoy your calculations. There's a worked calculation that your teachers may or may not let you see. Then, of course, I did lots more data. So 3 more trials in which I took 10 cubic centimeters of the mixed solution, and you can see there's the volume for the first, the volume for the second, about the same. And then I doubled up and took 20 cubic centimeters of my mixed solution, and of course you can see, as you would expect, it's going to take about twice as much of the acid to get to the various equivalence points, to get to the, first of all, the phenolphthalein color change, then the methyl orange color change, because I've doubled the volume.